Take your time. All right. How many of you have tried .NET Core already? So, and how many of you have tried Orchard Core? Are those the same people? More or less, yeah. All right. So, this is the agenda. I'm going to talk about tooling. I'm going to talk about .NET Standard, and I'm going to talk about C#. The slides I'm going to present are. It's a green presentation. The slides are recycled from presentations by my friends Matt Storgersen, Imo Landvert, and Zlatko Nezevic. I can never get his name right. It's his fault. Anyway. All right, so .NET Core is pretty much getting everywhere. That is not exactly true, and I'm going to get back to that in a few slides. But well, .NET Core can run on Windows, it can run on Mac, it can run on various flavors of Linux, it can run on Docker, and it can run on most of the processor architectures out there. And this is only going to get better. In terms of tooling, you can use Visual Studio, of course. I said Visual Studio 2017 here because of a change in tooling that I'm going to detail later. But if you want to use the latest version of the tooling, you need Visual Studio 2017, and there are no plans to make that available on earlier versions of Visual Studio. Sorry. You can also use any text editor of your choosing, and there are OmniSharp plugins for most of those. So OmniSharp is a little piece of open source software that basically provides IntelliSense services for editors. So if you can integrate that into something like Emacs, for example, you can actually get IntelliSense in there, which is pretty neat. There is a new thing called Visual Studio for Mac that you're going to be able to use, all you Mac lovers. There are a few of those here. Visual Studio for Mac actually is Xamarin Studio repackaged as Visual Studio. And you know, with some improvements, such as .NET Core support. There is an IDE that is being built right now by JetBrains that you might have heard of. And this is another cross-platform option to do .NET Core development. And of course, there is the CLI. And the CLI should almost be considered as an IDE in itself. The idea is that to develop with .NET Core, you should not have to have an IDE. You should be able to do everything with a plain text editor and the CLI. So the CLI currently is offering just a few commands such as .NET New, .NET Restore, .NET Test, .NET Run, but there are more commands that are on the way. I'm going to detail that as well. And you can also develop your own commands. So it's like an extensible text-based IDE in many ways. All right, so let's talk about the stuff that some of you resent. The project system. So .NET Core started with a new project system that was based on a JSON format. This is dead, I'm sorry. I'm one of the people who actually kind of resented that death. But I think I'm over it now. What about you? I'm looking at you specifically.
No, I'm not over it.
You're not over it. Absolutely. It's terrible. No. You will never be over it.
Absolutely never be over it.
Okay, so that's fine then. We can just ignore it and ignore you, I mean, and carry on.
2015.
What? Or you continue to use Project JSON on Visual Studio 2015 and just forever. And this is going to be Orchard Core. It's just going to use a project system that only it uses.
Absolutely, yeah.
Yeah, that makes total sense. Let's do that. Excellent. Yeah, so it will really be gone for good as soon as the version 1.0 of the tooling is out. But there is a nice command that's called .NET Migrate that is going to take your project JSON and transform it into the new format that is better now. Yes, it is. You can also open the project in Visual Studio 2017, and it's also going to prompt you to do the conversion. So it's a one-time conversion, and once it's done, you have a CS proj, and you're on your way. So we have a new and improved CS proj, because it's not the CS proj that you were using with previous versions of MS Build. It's a much leaner sort of CS proj that kind of eliminates all the problems that CS proj had before, except for XML. But is that really a problem?
Nope.
There you go. So the new CS proj is small, and I'm going to show some examples of that. It's really small. It's easy to manually edit. There is a lot less noise and a lot less stuff that you need to remember in order to author one of those files. We are not expecting people to actually, open a text editor and start typing those tags, but you could. It uses globs. So globs are those patterns where you say, okay, I want to compile all the files in this folder. So instead of specifying all the CS files one by one in your CS proj, like it was the case before, you just say, I want to compile everything that ends in CS. And that's that. That means this is really important in terms of merges, because if you've ever had to merge CS proj files or solution files, they are nasty. With globs, yeah, the CS proj almost never changes except when you add new dependencies or when you do some significant changes like that. But adding a file to the project is not going to change the CS proj, which means that it's just, you don't even have to merge it. It didn't change. There are no GUIDs anymore in there. We got rid of the GUIDs because we hate GUIDs, and so should you. It has a lower concept count. You don't necessarily need to understand all the subtleties of MS Build in order to understand those project files. The package references are now integrated into the CS proj. Previously, you had to use a separate file to manage your packages. So that file was understood by NuGet and by pretty much nothing else. Now all that is rolled into the CS proj, so you have one unique place where you can find everything related to your project. And as I said, you can easily migrate from project.json, either using the CLI or using Visual Studio.
Quick question on that.
Yep.
When you do that migration in .migrate, or if you open it in Visual Studio, do you know, does it delete the project.json for you?
It doesn't delete the whole project file. It puts it in a backup folder.
Okay.
It gives it a backup extension.
And there is a backup also for all the files.
Right. But it's still there.
Okay.
It's still there.
I opened Ocean Core I think in VS Code once, and I think it did the migration, but VS Code was still confused by the presence of the project.json files.
I see. Yeah, that should be fixed by 1.0.
Yeah.
And those backup files, you wouldn't push into source control. You would just delete them or leave them there for a while if you want to be super sure that you're not losing anything. But
your Nick, basically.
Yeah, poor Nick. Okay, so the main reason why we did that horrible thing is so that we can have a unique project system that works everywhere. It works in Xamarin, it works in Mono, which is pretty much the same. It works with .NET Core, it works with .NET Framework. It also means that you're going to be able to create references from anything to anything, and that is going to be really high value, and that's what justifies the whole transition. Okay, so you're still not happy, but. Okay, so here is what the default console application looks like once you've done .NET New. So if you've opened CS proj files before, this should really look a lot simpler. I mean, there is almost no noise in there except for the property group, which is still something that is not quite optimal, but it does look pretty good. And if you add packages to that, it's not much more complicated. You have a new section that appears that has your package references, and the package reference is just one tag with the name of the package and the version. And that is actually something that is reasonably easy to edit by hand, but you don't even have to. There are CLI commands that manage those package references, and you can also manage them through the NuGet dialog in Visual Studio.
Mm-hmm. Do they auto-complete as well, like on the pushing data?
Sorry?
Does it do the dynamic lookup and the auto-complete? Now when you can see which version?
Not yet, but that will come eventually, but yeah, not yet. So that's it may be the biggest advantage that project.json still has over this, but that will be fixed. Same thing for library project. So the library project is pretty much the same, except that it doesn't have the exe output type. But yeah, it's really simple. You're just saying that you're targeting the Microsoft.NET SDK. You want to compile for net standard. And there is also the notion of multi-targeting. If you want to target more than just net standard, you can actually put an S on that tag and say target frameworks instead of target framework, and then you can give a list, a comma-separated list of targets. So with the same project, you can compile against .NET Framework, .NET Core, or whatever. So this is very useful for library developers. For example, if you look at the repository for Newtonsoft JSON, you will see lots of projects in there. He should be able to get rid of those project files and condense that into one, in principle. Okay, so because of this new project system, now the SDK for .NET comes with a few additional moving pieces. So there is the notion of an SDK, which is something that is in addition to the command line, that contains all the tasks and targets for MS Build. That we use to build your projects. So that we just bundle that under the name SDK. So that's all the stuff that the IDEs and the CLI is going to use to manage your code. And really, it's a shared set of components that is going to be used by all the development environments here. And of course, it's not limited to those guys. Any other IDE can use them as well. Okay, so let's look at some of the CLI commands. So they are all constructed on the same model. So you have the .NET, which is the thing that's going to dispatch all the commands, and then you have a verb. And after the verb, you have some arguments. So that's the basic structure of all the commands. If you're familiar with Orchard, that should be very, very familiar, because it's pretty much the same thing that we're doing with the Orchard command line. There are a few commands that you may already know if you've used .NET Core before. So you can create a new project using .NET New. You can restore your packages from NuGet using .NET Restore. You can run your application using .NET Run, and when you do that, it's just going to build the application for you, and it's going to, when the application has finished running, it will remove the build artifacts. If you want to build and keep those artifacts around, you use .NET Build, and then you can .NET Run it. Then you have .NET Publish. .NET Publish is for taking your application and packaging it into something that you can then deploy. So it's going to create a big folder with everything that the application needs in order to run. And let's not forget that .NET Core is a side-by-side framework, which means that you can really deploy that stuff onto a machine that doesn't even have .NET Core installed. .NET Pack is what you use to package your NuGet packages. So if you create a library, now you can specify everything that NuGet needs in order to package in the CS proj. Once again, you have only one file where you define all those things, and .NET Pack is going to create the actual NuGet package that you can then publish to NuGet.org or distribute or whatever. And then you have .NET Test, and this is to run to launch the test runner. And now we have some more advanced commands, and those are new. They weren't on previous iterations of the CLI. So some of them we call CRUD commands because they have these lists of verbs, add, list, remove, and then they have an additional qualifier here. So for example, I said that you can add, remove packages using the command line. Now, that's the first command, the add, list, remove reference. This is how you manage your packages without having to crack open the CS proj and edit it by hand. Oh, no, sorry, I meant package, the second one, add, list, remove package. Reference is for referencing other projects. So you're referencing another CS proj, sorry. Then we have commands to manage the solution, file. So you can add and remove projects from a solution. The first time you add a project to a solution, it actually creates the solution file. And this is important because solution files are still not very nice to edit by hand. The solution format actually hasn't changed at this point. What else do we have? Oh yeah, we have those three commands here. You will probably not need those. They are used to call into MS-Build, NuGet, and VS Test directly. But if you're doing that, you might as well call msbuild.exe, and that would be pretty much the same thing. So those three they have their usefulness, but you probably don't need to know about them. And last but not least, you should know that you can add your own commands. And this is actually very easy. You create an executable, for example, you put it on the path somewhere, and if it's called .NET dash the name of the command that you want to implement, then it will just be found and be executed. So I don't know if you wanted to have an extension that triggers a gulp pipeline, for example. You could create a .NET-gulp.exe that does that, and then you would be able to do .NET gulp and whatever parameters after that. And you'd be able to extend the command line this way. So that's one way to extend it. You can also extend it using NuGet packages. Yeah, that you have basically two ways of doing that. Okay, so that was it for the tooling section of the presentation. Do you have any questions on that? Yes?
I read that there's a new templating engine also coming out as part of...
Yes. Yeah, so I didn't mention that because it's under a command that already exists, that's .NET New, but I should have mentioned that, yes, it's a completely new command, actually. Previously, .NET New it had basically three options. You had console application, library, or test project. Now you have, four. There was the ASP.NET application as well, but it was you didn't have a lot of choices. You would get a big, fat ASP.NET application, actually, and you would have no control over what gets in there. Now it's something that is much closer to Yeoman in that it can actually take options, and you can extend it with your own templates.
So when I was reading that, I thought maybe that's the way to go for Orchard Core and the code gen.
Maybe, yes. Yeah, so having a set of 4 chart commands extending the .NET CLI might be an interesting way to go. To be seen. I mean, you might want to conserve your own, command line driver, but yeah, it's definitely something to consider. Absolutely.
The thing with the publish in in classic .NET, it was never clear to me, like when you publish a web project from Visual Studio, pretty much everything inside of that folder gets into the published package.
Yeah.
Is there a way in .NET Core where you can specify things to be included? Is it based on the CS proj, or does it just take everything in the folder, or how does it work?
So it's based on the CS proj, yes.
Okay, good. So that means we no longer have to worry about things like getting the node modules folder inside of every publish.
Right. Yeah. If you can have content include nodes and stuff like that,
Perfect.
and it's MS build really. So it's the equivalent of doing publish from Visual Studio.
Just on those new templates, I think the stuff that I showed, which is the SPA services, there's an option to do .NET New Angular, which uses those, that set of technologies.
Yeah.
And
Yeah. Nick, you had a question?
I forgot what it was, so it's okay.
Yeah, it's probably for the best.
Yeah, probably. I think it was about solution files actually.
Okay.
I remember there was a requirement that we didn't need to use a solution file anymore for running stuff in like Visual Studio Code. I don't know if that's true or not.
I'm not exactly sure.
Yeah, it was just based on folder structure.
Well,
Is that
yeah,
still the
you
case?
can go pretty far without a solution. You can begin with a CS proj. I mean, solutions by definition are only useful when you have more than one project that you want to manage as one single thing,
But
right?
in VS Code, you can't create a new solution.
So I don't know how aware the C# extension for VS Code is. I don't know how far it goes.
So from my understanding, it goes as far as you just select your specific project, and you'll get IntelliSense, you'll get all the goodness that Visual Studio gives you by doing that for that specific project.
Right, okay.
But what do you mean by?
Yeah.
So I just thought that the requirement to have a solution file went outside of. There's no requirement.
Well, the thing is, even without solution, you still have project references, right?
Yes.
So it actually removes a lot of what the solution was useful for. Because you have those project references, it means that the IDE can explore those relationships and provide you IntelliSense for everything. So you should be good without a solution in most cases.
Okay.
The solution is mostly useful, I would say, so that you can work on it as a single unit. So let's say, for example, that you want to run all the test projects in your solution, or you want to restore everything, all the packages in the solution in one operation, you can do that.
You can restore on individual solutions, and whatever is contained in that solution will be being restored. So if you have multiple solutions next to each other, you can group the amount of work that's restored or built based off of what your .NET restoring. So .NET restore solution 1, .NET restore solution 2.
Right, I see. Okay, that's cool.
Yep. Okay. Net standard. Okay. So, how many of you are familiar with .NET Standard? Yeah, so maybe 10 of you. Okay. So, .NET Standard is a new concept that you could describe as PCLs done right. PCLs being portable. What does it stand for again?
Class library.
Portable class library. Yeah, I blanked out on the C here. The problem with portable class libraries is that, well, yeah, there were many issues. But this diagram here should show you a number of interesting things. So what's the problem here is the vertical lines between those three guys here. Because it goes too low. There is not enough that is common between .NET Framework, .NET Core, and Mono here. The class libraries are different. So that means that they are implemented 3 times. That you need expertise in all 3. We are losing opportunities to reuse code all over the place, and it makes it all the more difficult for us to innovate and carry all that forward at the same time. So the idea behind .NET Standard is to unify one more layer, because we already had some commonalities here. I mean, the compiler was already the same. It wasn't always that way, but it was. Same languages, some of the runtime components are reused, but what .NET Standard is doing is that it's unifying that layer here, so that now what is unique between them really is unique between them. It's what makes them, what justifies their existence almost. I mean, when you look at Xamarin, okay, it's doing iOS, Android, and OS X, which none of the others are doing. Well, except for OS X. But .NET Core is the cross-platform open source one. .NET Framework is the Windows implementation of .NET. So that makes a lot more sense. And it also means, so that it's useful for us, but it also means that library developers can also have one single expertise, and they can just ship bits that are going to be able to target all of those with one single library. So you only need to master .NET Standard, and then you can target all of those. And you can run your code pretty much everywhere. And for us, it also means that we can innovate faster. Okay, so specifically, a way to see .NET Standard is if you're familiar with POSIX. Who is familiar with POSIX here? Okay, so it's a very useful metaphor that 5 persons in this room understand. So POSIX is a set of contracts that Unix implementations had to implement. And .NET Standard is also a set of contracts that .NET implementations have to implement. So in terms of code, it would look a little like this, where you have the implementation of a contract. So .NET Core or .NET Framework is an implementation, and the .NET Standard is the interface that they implement. So it's a set of APIs, really, that everyone has to implement. So if you target that set of API, you can run everywhere it's implemented. But it's also something a little more concrete than a contract. It actually comes as a NuGet package, and that NuGet package is a facade that you compile against. So it's a set of hooks that you program against, and then when you actually run the code, it actually calls into the specific implementations. So that NuGet package is really mostly something that you use at dev time. Does this make sense? Okay. So yeah, when you look for packages, you can actually find the .NET Standard class libraries in there. Okay. So another thing that's interesting about .NET Standard is the way that it's versioned, and that was actually one of the issues we had with PCLs. There is a number of guarantees that you get with .NET Standard. One is that if the version number is higher, it means that you also get all the APIs that previous versions implemented. Kind of makes sense, you know, it's called backwards compatibility, after all. But yeah, this is a way to see it. Each new version is more than the previous one. And it may seem completely obvious, but if you've known PCLs, it's really not. And another consequence of this is that the lower the version of .NET Standard you target, the more places you can run, because it lowers the bar of what the target framework has to implement. So the lower the bar, the easier it is to implement, so the more places it's going to be implemented. But you know, I would say that targeting 1.3 or 1.6 almost guarantees that you can run on .NET. Well, it guarantees that you can run on the latest .NET Framework, on .NET Core, on Mono, so you're good with that. But .NET Standard 2 is what is going to be really interesting here, because, well, you know, this has taken some time. .NET Standard was introduced with .NET Core. 1.0. And .NET Core being a completely new mostly new implementation of .NET, we couldn't ship everything at once. So it is still lagging behind .NET Framework in terms of API surface. And that is taking time. We're taking time to catch up here. The main goal of .NET Standard 2.0 is to do that catching up, so that the API surface of .NET Standard 2.0 is almost the same as the API surface of the .NET Framework, except for those APIs that are really highly specialized for Windows. So the number of APIs has more than doubled. If you look at those numbers here, they are pretty impressive, I think. But the point being that, yeah, this is pretty much the same surface area as .NET Framework. And there is a little detail that I find really neat, which is that so far, if you wanted to target .NET Standard, you had to compare against .NET Standard. With .NET Standard 2.0, you will be able actually to try to reuse libraries that haven't even been recompiled. So that means that a very large number of NuGet packages that you can find on nuget.org, you are going to be able to just include in your project, and they might work. They might not, but they might work. So at least we are not going to tell you, yeah, well, okay, well, that may be using only APIs that you actually have, but no, you will have to find the source code somewhere and recompile that. So we are not going to say that. You are going to be able to at least attempt to use them, which I find is pretty neat. Okay, so here are some of the APIs that are covered in .NET Standard 2.0. So pick your favorite thing missing from .NET Standard 1.6 and celebrate. It's probably here. So we have binary serialization. We have all the reflection APIs that are back. All that. Enjoy. Any questions about .NET Standard? Yes?
You know, sort of dynamic image resizing and things like that, is that in .NET Core?
Okay, so the question is image resizing. What about that?
Like you know, Image Magic, WPF, GDI, that type of stuff.
Yeah. So that's a great question, and I know the answer because I wrote a blog post about it. Okay, so the part of .NET Framework that does image processing is under a namespace called System Drawing. And System Drawing is implemented using a technology that's called GDI Plus in Windows, and that is technology that is Windows specific. It doesn't mean that the APIs under System Drawing are super Windows-y. They are really, you know, just drawing APIs. So you can actually could implement that on Linux and the Mac. And actually, that's exactly what Xamarin has done to be able to run System Drawing against iOS and Android. And a guy took that source code and made it work on Linux and Mac as well. So there is a library called Core Compat System Drawing that you can find on NuGet, and that is actually a cross-platform version of System Drawing. Not shipped by Microsoft. Okay. But it's mostly Xamarin code. Now you have other options. You have some really, really good options, and I encourage you to check out my blog post to see I made a performance comparison of them. I put some code samples in there. So yeah, check it out. So there are third-party options. The lowest cost if you have existing code using System Drawing is to use that Core Compat library.
But there's now plans for Microsoft to package it up? No,
there are no plans, but you know, we're thinking about it because we know how important it is to have some drawing capabilities. It might be something different. So it might be a new implementation of System Drawing. It might be a new API, maybe based on Skia. Skia Sharp is one of the best libraries that you can use to to do 2D nowadays, and it works on .NET Core today. We don't know yet, but we'd like to ship something out of the box, but nothing's been decided yet. All right. Okay, so let's switch to C# then. How am I doing on time? Yeah. Okay, so C# is popular. People like it. A little less than Java. What's up with that? What's wrong with you? Well, it depends what you mean by popular. This is from Stack Overflow. It's mostly what people use more than what people like. If you want to look at what people like, well, yeah, C# is not doing bad either. But you have some young guys such as Rust and Swift and the hipster language F# there, and Go and stuff like that. But C# is doing well for a 15-year-old language. It's still evolving. So let's look at this. So C# is definitely the most used language in .NET. There is no doubt about that. It means that the language team is mostly leading with C#. That is not exactly true, because there is a lot of innovation happening in F# that in some cases makes its way to C#. One of the basic tenets of the C# team is that they keep up with the industry, and in some cases they move it forward. I mean, we've seen innovations in the past, such as the async keyword or link, that have really been very influential in the past. So we're going to continue in that trend, hopefully. They really focus on those improvements that are going to improve the lives of maximized number of C# developers. And there is also the notion of responsibility when modifying a language, evolving a language that is so widely used as C#. You don't want to introduce concepts that are going to make the language too difficult to understand, or that are going to betray the basic spirit of the language. So it still needs to be C# and look like C#. All right, so let's look at some of the C#7 is actually out there. You can use it. You know that, right? So let's look at some of the stuff that it provides. This is a pretty minor improvement, but the times when you need it, it's actually useful. We have binary literals now, and digit separators, so you can just put underscores in your numbers and they look nicer. Much more useful deconstructions. So this goes together with the notion of a tuple, which is a notion that has existed in many languages for a very long time, but that C# didn't have. Now, a function can actually return a multiple results, basically. And then you can assign those results. Do I have a pointer here? Yeah. Does this work? Yeah. And then you can assign the different parts of your function results to variables directly. This is called deconstruction. And then you can use those new variables here, well, wherever you want. Does this make sense? The signature of tally, I think I must, yeah, I have it here. So great question. Yeah, so the way this was designed is that the signature of the return type is made to look exactly like what you would put in an argument list. So what you return looks like what you pass in. Okay?
Is that sugar for a tuple?
Hmm?
Is it really a tuple and that's just sugar, like compilation sugar?
What do you mean by is it a tuple? Is it the existing tuple type? No.
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 Okay. The new tuple type.
Yeah. Because the tuple type has, properties such as item 1, item 2, and
Right.
we can do better. Here you can actually name the parts of your tuple. So it looks a lot nicer. So going with that, we have tuple literals. So this is how you define one of those, how you describe one of those as a literal. This is only, I'm just going to give a laundry list of features. So there is no, the flow may not be great here, but I hope you can follow along. So we have the new notion of local functions. So this is going to be useful anytime you have to reuse a little bit of logic inside of a very closed scope, and you don't want to create a utility class or something like that. You just define your function in line, and then you can use it. Then we have the possibility of switching on any value. So this is much relaxed in comparison with previous versions of C#, but there is also the idea of pattern matching that gets into the mix. How many of you are familiar with pattern matching? Yeah. So yeah, indeed, it's a concept that comes from functional languages, where you can apply specific logic to different shapes of data in ways that are very explicit and very expressive. Very expressive. So in this case here, we have something in that v variable. We don't know what it is. It's basically an object, okay? Because this thing is an array of objects, so v is completely unknown at this point. And what this is saying is, okay, if v is an integer, then I want to treat it as an integer. So, okay, so I'm saying, if v is an integer, I will rename it I in the scope of that case here, and I can use it as an integer directly. Okay? So when you have something that is unknown like that, you can break it down into several different cases depending on the shape of your incoming data. So this is extremely useful when you're getting a stream of data from somewhere that is unknown in advance, for example, or when you're getting dynamic objects, or the kind of stuff, the kind of crazy stuff we do in Orchard all the time. So I hope you see the usefulness of this. So in the second case here, we are doing a little more than that. We are saying, okay, well, if v in this case is an object array, let's call it A. Okay, but let's execute this code here only on the condition that the length property of that object array is more than 0. So a non-empty array, basically. This is saying if v is a non-empty array, then okay, well, tally it. Okay? Make sense? Okay, so this is C#7. So now I'm going to show you some possible features of future versions of C#. As you may or may not know, the design process for C# is completely open. It's happening on GitHub. So all of those proposals are somewhere on GitHub. You can find them. You can vote for them. You can propose different designs. You can criticize it. You can do all those things. Okay? There is no clear shape for the moment about what future versions of C# will be about, really. In the past, we had one release that was all about generics. We had one that was all about dynamic. There is not yet any clear pattern emerging yet. So we are still pretty early in those releases. So there are many ideas. Some will stick, some won't. Another thing that is kind of a change with previous versions is that there will be point versions, so smaller, more incremental versions of C#. And this is made possible because the compiler now is Roslyn based, which means that it's very easy to ship new versions of C#. And people can adopt them or not in their projects. And it's very easy to do so, and it all compiles to IR anyway, so it doesn't pose any compatibility problem. And it's pretty neat that a project can actually decide to adopt new versions of the language. And there will also be some major releases, but those will be as needed when some major feature areas appear. Okay, so let's look at the design tenets for the future. Everything that makes it into the language needs to be expressive. It needs to be convenient, which means that it needs to take something that used to be complicated, needlessly complicated, and make it much simpler. And it shouldn't degrade performance. And finally, if possible, it should actually prevent more bugs than it creates, which kind of makes sense. All right, so here is one. We've seen some pattern matching. We can go much farther than that. So this is one example where we look at an object here, and we're asking the question, is it a point? Okay, well, if it is a point, then we want to actually deconstruct it. We've seen deconstruction before, where we take parts of an object and we assign it to different variables. So here we are doing that. We are taking the second coordinate of that point, and we're assigning it to the variable y. What about the first coordinate? Well, what this underscore is saying is we don't care. We are not going to use that piece of the data. So we're just throwing it away. Okay? So what this is saying is if O is a point, then take the second coordinate and write it out. Okay? Make sense? You can also do that. This is pretty much the same thing, but using a slightly different syntax. So this is using another deconstruction syntax that is close to the initialization syntax for objects. But it's the same idea. This code is doing the same thing. Let's see. Yeah, so this is more pattern matching here. So the layout of the code here is a little different. This is using lambdas here. So previously we've seen the case statement, the switch case statement. Here we are using lambdas, using a match construct here. So this is new. This is a more compact way of expressing the pattern matching. That it introduces some new syntax, but previously with the switch case, I had to put breaks at the end of the cases, all that stuff that comes from old C. So this is a little nicer, a little more compact, and a little more functional in form. So well, should be pretty easy to understand what this is doing. So here we have an object O, and if it's an integer, then this expression here will return the string saying number and the integer. So if you look at all those cases first, let's look at what they return. What they all have in common is that they all return a string. Okay? So the compiler will know that the return expression of that whole block here is going to be a string. So it can infer that S here, the return value of all that stuff, is going to be a string. So S is going to contain a string at the end of this evaluation. Okay, so the second one here, if it's a point, deconstruct it as its first and second coordinate and output a string that just has those two coordinates formatted as a string. Third case here, if it's a string that has a positive length, then just return that string. If it's null, return a string containing null. And if it's whatever, just return a string containing other. Okay? So what is an empty string going to return? Other. Yes. Making sense? Any questions? Okay.
Can you do matching by value only?
Can you do matching by value? Well, that value will have a type, so...
But can you do like match int 0, int 1, int 2?
Well, if you're going to do that, you should just do a switch.
I was thinking that
Yeah.
it's more, it's
Yeah.
less verbose because you don't have the breaks and all that.
Maybe that could work. Submit it on GitHub if it hasn't already. Yeah. Yeah. Could you do? Yeah, you would probably have to do int I equals 0, int I equals.
So int I when I equals.
When I equals 0. Yeah. Sébastien? Yeah. Yeah, but it's maybe there is a way to express that in a more compact way. I don't know. Yeah, another thing that would be possible is to use tuples in patterns, and this one can be pretty subtle. But if you have experience with functional languages, you should feel right at home. This is basically a state machine. So here we are matching on two things: a state and a request to change that state. Okay? So you have an inward state, a request to change that state, an operation to perform on that state, and then we are going to return another state. Okay? So here what this is saying is that if the state is closed and we are asking to open it, then we return an opened state. If the state was closed and we're asking to lock it, it's already locked, so it's still, oh no, locked is different. Okay, so we're returning locked. If it was opened and we ask to close it, then it becomes closed. If it's locked and we unlock it, now it's only closed but unlocked. Okay, making sense? So you have three states: open, closed, locked. And this describes all the way you can transition from one state to the other.
So here you're doing exactly what I asked, actually.
Yeah. Actually, yeah, that would work. Absolutely. Yeah. Good point. He's following really closely. Yeah, and if it's whatever else, then it's not something that we've predicted. Yes?
Does the match have something like a type parameter so you can dictate what's the return type is going to be or something like that?
Well, it's inferred here.
Well, yeah, I know it's inferred, but like just to make sure you don't mess it up.
I don't know. That's an interesting question. I think usually the idea in that kind of pattern matching is that part of the point is actually to be able to infer as much as possible, so that it's still extremely type safe. It's actually in most cases more type safe than usual object-oriented programming, while being very expressive with as little noise as possible. If you do F#, you only specify types when you absolutely need to, and this kind of follows the same kind of paradigm. I don't know if you can add the types if you want. I don't know.
Of course, in most cases you won't need.
Yeah. Yeah, I don't know. Yeah, so now we're switching to a different area, which is nullable and non-nullable types. And this is a delicate one. This was one of the candidates for C#7 actually, and it didn't quite make it. I don't know why exactly, but I'm suspecting it was because it was still a little too controversial. The problem is that if we were designing a new language, we would know pretty much how to avoid the null problems. But we are not designing a new language. We're designing a language where null already exists and is everywhere. So the idea here is to make it easier to manage null while keeping backwards compatibility. So the idea here is to be able to specify those cases where something can be null. So the way you do that is that you add that additional question mark, which is it's symmetrical to the bang that you have on nullable value types. So this is the flip side of it. It's non-nullable. It introduces non-nullable reference types. So by specifying the question mark, you're saying, yeah, I am aware that this is going to be possibly null. And if I'm not specifying it, the idea is that you would start getting warnings. So it's backwards compatible, but it's going to create new warnings on existing code. And this is probably what makes it a little controversial, because not everybody likes it. Warnings are by many considered like errors. They are actually handled like errors by many people. So it's not something that you want to do lightly. But arguably it's for the best, because null refs are a real problem and it's costing a lot of money to a lot of people. So this is probably something that you are going to have to opt into. So that you don't get those warnings unless you want them. But once you want them, it should find bugs in existing code. So that is a good thing. So once this is activated, you have to explicitly say, yeah, I really want this to be nullable. And once that is done, then it can infer a number of things, and it can give you warnings in cases that look suspicious. Any questions on this? All right. Yeah, more cases where you would get warnings. So you would not get warnings in cases where we can infer that this cannot be null given the flow of the program. Yeah, if something is nullable, well, you would need to check first, and then it would stop screaming. There you go. Oh yeah, shouldn't have passed this one. Oh, whoa. Yeah. Okay. Yeah. So the bank here is kind of here. You're basically saying, yeah, well, yeah. It will throw it if it has to. And
is it the same as the Elvis operator?
As the what?
As the the question mark period that we have in C# 6.
No, this is actually going to throw.
Oh, okay, it'll throw. All right.
Yeah.
And if on the line where you have right line and dot length 2 lines up.
Yeah.
If you use the Elvis operator on that one, would you get rid of the warning thing?
Yes.
All right. Okay. Cool.
Okay, I'm almost out of time, so I'll be fast. This is also something that the team has wanted for a while. It's an extension of the idea of async await. There are lots of cases where you want to await on something that is enumerable. And the pattern is not quite so obvious. It's not obvious to get perfectly right. So what this is introducing is the possibility of doing for each await, which means that it will actually await on an asynchronous version of move next on your enumerable. So it introduces a new iAsync enumerable interface that is an async version of enumerable. So this is a version of enumerable where every time you iterate, it's asynchronous.
Is that like reactive extensions?
Yeah. It's very similar. It's not exactly the same pattern, because one is the opposite of the other, more or less. They are kind of dual. Yeah, same thing with using. This is an asynchronous version of the iDisposable pattern. So here you can await on the disposing of the object can itself be asynchronous. So this is a feature that I personally don't quite understand. Tell me what you think about it. It's the possibility of introducing default implementations on interfaces. And personally, I'm probably a little daft because I don't get why this is not an abstract class.
Because you could implement any of the.
Yeah, it's a good point. You can do that. Yeah. Yeah.
Previous slide,
But should you?
is that existing or non-existing?
That's a future feature. You could, yeah. No, you couldn't implement the, well, you could implement something like that, but you would have to manually, iterate the thing. You wouldn't be able to use for each and using. You would have to write code for it. Yeah. More default implementations. Yeah, it would also work for properties. And that one I really like. Okay, and I know I'm out of time, but I really want to take the time for this one and the next one because they are actually relevant to our chart. Records are new types that are made to represent immutable data structures. And they are very useful in data processing and and basically it's a shortcut for all that code here. So every time you have to define an object that is immutable, that has some default constructors, default deconstructors, you want to define equality, hash codes, and so on. Instead of doing that, which is very repetitive, you can just create a record. You like that?
Yeah.
Okay. And here is a feature that goes with it. And that one is even sweeter. Can you see why?
Dependency injection.
Yes. Dependency injection in the language. So today, if you look at any class in our chart, any service, anything that does anything in our chart that needs dependencies, the first thing you do is that you build a constructor that takes all those dependencies in. Then you repeat yourself by creating the private properties where you're going to store those dependencies, right? And then you can start writing significant code. You can actually start using those dependencies. Well, what this is doing is that instead you can define those private fields right in the constructor. And more than that, the constructor is actually merged with the class definition. Okay? So there is only one of those. You can still write ordinary constructors in the body of the class. But this is such a shortcut. Nick, you look.
Not sold on. I like the last one because it looks.
Think about it.
The last one. I'm not sure about.
Okay, take a class in our chart, one that has many dependencies, and rewrite it with this. And tell me if you still don't like it.
I just don't like it.
It's okay. I get it. It's unusual. It's doing stuff that you're not used to. But my claim is that you're gonna get used to it and you're gonna love it. Just like CSproj.
Wasn't there an implementation where you didn't even have to define your private variables at all?
Oh, you don't have to. Those are
two lines there.
Those are properties.
Okay.
Yeah, it's your private.
Those are accessors for those guys. I mean, they are just surfacing those as public properties.
Yeah, like underscore.
But if you remove those, you can still use those guys inside of your code.
Yeah.
Oh, so I can just refer to user manager with a lowercase u somewhere
Yeah.
in my code.
Yeah, you don't have to have that. This is only if you want to publicly expose them.
Oh.
Yeah. Does it make it better?
A little bit.
There you go. Okay, do you like that?
Yeah.
So we can move
Okay, so this feature, it might not make it again. So if you like it, you know what to do. You go to GitHub and you tell them that you like it and you want it.
If you really
Okay?
like it, you can use it in TypeScript already.
Yes.
Yeah.
Yes. Guess where it comes from?
If you need it, you can install an extension.
Hmm?
With automatic private blah, blah, blah.
Yeah, but it still results in more code than you need.
But you don't have to type.
You don't have to type it, but you have to maintain it, and you don't like it. Shit. I'm disappointed in you, Sebastian.
You could say, don't use it, it's compatible. But I'm like, I don't unhappy because I don't want people to use
Why?
it. I think it's harder to read.
Yeah, I
to
agree.
kind of construct to understand parentheses, but what is that? Constructor parentheses, the class parentheses, and the
Okay, let's read it.
Feels obfuscating.
No, let's read it. What it says is, okay, I'm creating a public class called account controller that is taking a dependency that is a user manager, another dependency that is a sign-in manager, and another dependency. It's the class that takes those dependencies. So it makes sense.
With the naming, you need to start putting the underscore in there, otherwise further down you're going to get confused between your method level variables and these.
Sure.
But then
This-
that looks weird as well, having underscores in your...
Yeah, there are different conventions and.
why we don't want to do it. Why we don't want to do it.
Why they don't want to do it? Because language designers are not application developers, and they don't know how important dependency injection is. And actually, the way you sell it to them is by telling them that it makes this easier. So Mads wants to couple this feature with the other one and sell it as one big unit, but selling this feature on its own to language developers is very difficult because they don't see the point. So we need to sell it to them. We need to tell them this is useful and it will.
Becoming a bunch of lots of different things to express the same thing, and they don't understand. They ignore the language.
Yeah, sure. They don't like duplication of concepts. Yeah. Okay, I'm almost done. Again, with immutable objects, you know, it's when you want to create a new immutable object from an existing one, they are introducing some interesting ways to do that. So the second one here is saying, I want a copy of the first point, but with the first coordinate replaced by this expression.
I have a conclusion for your talk. I'm afraid that C# grammar becomes harder than French grammar. There's no accents there.
You can learn it piece by piece. You don't have to learn everything at once. And frankly, this is easier than LINQ. Okay? Huh? You don't use LINQ. Well, you can not use LINQ. This is great. You can. Okay. Also, you're going to be able to do not just extension methods, but also extension properties, static extensions, and all that stuff. Yeah, I'm done.